Okay, let's look at number. All right, I'm gonna have to make this one up. All right, suppose we had this. Suppose we had 6. This is gonna be like number 1. We had 6 plus 3x divided by x minus 2.
Because it's got a whole number.
Okay, so remember, you want to add and subtract fractions, rational expressions. So you got to make sure you rewrite it using the same denominator. What's the LCD here?
X minus 2.
X minus 2, because you can think of that 6 as 6 over 1. All right, but remember, the first thing you need to do is factor, right? And I can't factor this,
No.
but the first thing you would do is factor. That's what we did last class here on that worksheet part A you just turned in. Now, once you factor, you find the LCD. So is the LCD here?
X minus 1.
X minus 2.
X minus 2. Once you find the LCD, what was that next step?
Due to the top, whatever you have to do to the bottom.
That's not what I'm looking for an answer. What's the next step?
Create
Write
equivalent
equivalent
fractions.
fractions. Write equivalent fractions. So I'm going to write 2 fractions with what denominator?
X minus
X minus 2. All right, so then you ask yourself, I have a 1, this is what I need. So what's missing? X minus 2. So I'm going to say times x minus 2 times x minus 2. Now be careful, really, the 6 is being multiplied by all of this, right?
Mm-hmm.
All right, and then you distribute. So what's going to be the numerator?
6x minus 12.
Y'all agree? Okay. Over here, here's what I have. Here's what I need. It's the same thing. So the denominators are the same. The numerators have to be
3x.
the same. Okay, so once you find the LCD, then the next step is to write as one fraction. So my next step is going to be, the number is going to be x minus 2. So you're going to say 6x minus 12 plus 3x, right? Combine like terms. What do I get?
9x minus 12.
Over.
X minus 2.
All right, now when you got your worksheet back, some of you are. Now this is not factor. The denominator is just x minus 2, but if it was x minus 2 times 3x minus 6, leave it alone. Leave it in factored form. A couple of you were multiplying it all out. I'm not sure why you were doing that. Everything should be in factored form. Okay? Now in the numerator, I can factor that, but it's not going to help because what's the GCF here?
A 3.
A 3. And when you factor it, you're going to get 3 times what?
3x minus 4.
And it didn't help me because nothing divides out.
But there were a couple of them on the homework to where if you factored it out, like you had an x minus 2 on the bottom, you'd have an x minus 2 on top.
Then you would reduce. Yes, you have to reduce at the end. Yep.
So you just leave it out or leave it as.
You could leave it like this or like this.
If it doesn't.
Yeah, yeah, but if you could factor and it does reduce, you need to reduce.
Yeah.
All right, so let's look at let's say 50. All right, let's do 53. 53. All right, so in 53, you have 13 divided by x squared minus 5x plus 6 minus 5 divided by x minus 6.
Factor the first.
So it's the first step.
Factor the first denominator.
Yeah, so you got factor your denominators.
2 binomials with x.
So the two binomials,
X.
xx,
6, 1.
6 and 1. The last sign's positive, so that's the easy kind.
Right.
They're both going to be
Negative.
negative.
X minus 3, or you changed it?
What now?
On 53, is it x minus 3 or is it x minus So you changed it, or I can't see.
That's x minus 6 times x minus 1. That wasn't a 3 and a 2 because 3 and 2 is not going to work.
No, it's
Oh, I'm so sorry.
problem.
No, I'm wrong.
X minus 3.
I'm wrong. That's not correct because what's this? Minus 7x.
So,
That doesn't work.
so when I'm, okay.
Yeah.
When I'm positive,
So it has to be what? 3 and 2. So it's x minus 3 times what?
X minus 2.
X minus 2. Okay? Now make sure I wrote the last fraction correct.
It's X minus 3.
Oh, it's x minus 3?
5
So that's what you're asking?
Yes.
Oh, I'm sorry. I'm looking on the side and yeah, there's not a lot of light right here, so I could have, yeah, I did. So it's x minus 3. I'm sorry. And I think the reason why I put x minus 6, what I even think about, is because that was an x minus 6.
All right.
Okay. So don't forget, change that to x minus 3. Okay, now what's the LCD? X minus 3 times
X minus 2.
x minus 2. So the next step is to write
Equivalent fraction.
equivalent fractions. So you're going to write two fractions with that LCD.
The left side's going to be the same. And the right side, you got to multiply by
All right.
X minus 2.
Now, on the first fraction, this denominator is exactly as your LCD, so you just rewrite the numerators. So that's be 13, right? Over here, what's missing?
X minus 2.
So I got to multiply x minus 2. What I do to the denominator, I do to the numerator,
5x minus 2.
and then distribute.
5x minus 10.
So that's 5x minus 10. All right, that's where we're at. Now can I write as one fraction?
Yeah.
Yes, except you got to be careful with the subtraction right here. So really you're saying 13 subtract in parentheses what am I subtracting?
5x minus 10.
5x minus 10. Now you can skip that step, some of you, and just you knew that it was going to be
Minus
13
5x plus 10.
minus 5x plus 10. All right, distribute, you're going to get 13 minus 5x plus 10 divided by x minus 3 times x minus 2. Combine like terms, I get negative 5x plus 23
Yeah.
over x minus 3 times x minus 2.
That's your answer.
Now remember the next step is to factor and reduce. This is simplify, but can I do anything with that numerator?
No.
No. So that's it. Now don't waste your time and multiply this out, because if you multiply it out and you multiplied it wrong, you can be upset because it'll take points away from you.
Right.
Because some of you are going from here and then you're going to say, well, I'm going to just go and multiply the denominator out. Well, you do that and you have an error, you're not going to get your full points. Leave it alone. Leave it in factored form.
Hey, if that's less work you want us to do and you're happy with that answer, I'm fine with it.
All right, let's look at let's look at 49. Okay, 49, you have 5 divided by 2 minus x, and that was on that worksheet y'all turned in, or it was similar to it. 5 divided by 2 minus x plus x divided by 2x minus 4.
All right.
Make sure I wrote it correctly. All right.
Factor out a 2 on the second.
All right, so you could factor that second denominator. So that's 2 times
X minus 2.
x minus 2. All right,
And
so
you
it's
got
so
opposite.
all right, so right. So don't say the LCD is 2 minus x times 2 times x minus 2. That's not the least common denominator. That's a common denominator, but it's not the least. You got to use the least. So you got to notice that 2 minus x and x minus 2 are
Opposite.
opposites. Now, remember what we did? We rewrote one of them. It doesn't matter which one, but since that's the only one by itself, I'm going to take it from here. It doesn't matter. You can factor out the negative 1 from here. It does not matter. I can do it both ways if you need to. But if you factor out negative 1 from here, you're going to say negative 1 times what?
2. I mean,
X
X
minus
minus
2.
2.
X minus 2. Now, remember, we circle this negative 1. We put in the numerator.
To the top.
So that's really negative 5 divided by what?
X minus 2.
Plus x divided by
2x minus 2.
2 times x minus 2. All right. So now what's the LCD?
It's going to be 2x minus 2, and then x minus
2 times
x minus 2.
x minus 2. That's your LCD. So notice what we did. You had to do that in that worksheet.
Okay.
So there's your LCD.
So we'll rewrite equivalent.
Okay, so now you're going to do the equivalent fractions. 2 times x minus 2. All right, now
Right side's the same.
here, what's missing?
The 2.
So you got to say
Multiply
times
by
2 times 2. So what's the numerator?
Positive 10.
Nope,
2 times a negative 5?
negative 10.
No. Okay. My bad.
Over here, the denominators are the same, so the numerators have to be the same. And so you get x minus 10 divided by 2 times x minus 2. Is that correct? Yes or no?
Yes.
Can I go any further with this?
Yeah, you can.
How? Oh, no, no, no. That's, we can only reduce factors.
Right.
X minus 10 is a factor by itself.
Yeah, you do.
Okay, that's it. You're done.
Okay, let me make sure I remember that. So I'm saying the same thing.
All right, let's look at,
You can only reduce the whole thing.
okay, let's look at 60.
But if there was, like, let's say, a 4 in front of that x up there, then you could.
You could factor out a 2 and you could reduce the 2's and some other things, okay?
I think we have one on the one like that too.
All right, 60, you have 6 divided by 5y squared minus 25y plus 30 minus 2 divided by 4y squared minus 8y.
On the left one, you got 5y and y. 2 binomial.
All right, so what are you going to do?
Factor the first denominator first.
All right, so how are you going to factor that first denominator?
Two binomials.
Nope,
No.
take out the 5.
Oh,
Yeah, because you can
okay.
get rid of the with the 25.
See, now, when finding LCD, it is important that you factor correctly. So you have to do the GCF first. So the GCF is 5, so you got to say 5 times
Y squared
y squared
minus
5y
5y
plus 6.
Plus 6.
Now do the 2 binomials with this. Okay, so it's going to be 6 and 1?
Y and y.
Nope, 3 and 2, right?
No.
No, he's
No.
right. He's got it right. He's got it right.
Because the last sign's positive. All right, so 3 and 2. Over here, how can I factor this one?
Factor out a 4.
4y. And you get,
Y minus 2.
okay.
Then
All right, so let's talk about the LCD now.
you got a 5.
Do the coefficients first. You have a 5 and a 4. What's the LCD?
20.
20. All right, let's talk about the, let's do that other y right here. So there's a y here, right?
Mm-hmm.
Are there any factors of y here?
No.
So how many do I need?
1.
1.
20y.
Now let's talk about our other factors. I have a y minus 3 here.
You gotta put
I don't have any here. How many do I need?
1.
Then I have y minus 2 here. I have 1 here as well. How many do I need?
1.
So that takes care of your LCD, right?
Mm-hmm.
Okay, so what's the next step?
Equivalent fractions.
So 20y times y minus 3, y minus 2, 20y, y minus 3, y minus 2. Okay, now look at what you have. In the first one, look at what you have and what you need. I have a 5. I need a what? 20.
20.
What do I need to multiply that by?
Both of them by 4.
4. I have the y minus 3. I have a y minus 2. So what else am I missing? The y. So what do I need to multiply that first fraction by? 5y. So time, not 5y,
4y.
4y. 4y. Make sure you understand that before I go on.
Yeah.
All right, so what did you do the denominator? I got to do the numerator. So what's going to be the numerator?
4y times 6, so 24y.
Okay, now let's look at the next one. I have a 4, I need a 20, so what do I need to multiply that by?
5,
I have a y's, I have a y minus 2, so what's missing?
y minus 3.
Y times, 5 times y minus 3, right?
So 4y.
I got to say times 5 times y minus 3 times 5 times y minus 3. Y'all agree what I just did?
Mhm.
Okay. All right, so I got to put this numerator here. So how are you going to deal with this right here? Very good. So 2 times 5 is 10, and then distribute the 10. So that'll be 10y
minus 30.
minus 30. 10y minus 30.
Okay.
All right. Now, once you do that, what's the next step?
Factor, you can factor.
Write it as one fraction.
24y.
So now I'm going to get 24y
Minus
minus
10y.
this numerator right here. So it's in parentheses 10y minus 30. Now you could have skipped that part and just said 24y minus 10y plus 30.
Right.
So 24y minus 10y
Plus 30.
plus 30.
So 14y plus 30.
20y, y minus 3, y minus 2. All right, combine like terms. 10y plus 30.
No.
14y plus 30
14y plus 30, yeah.
over 20y, y minus 3, y minus 2. All right, so that's where we're at.
Mhm.
I got any question at this point?
No.
Okay, am I done? No, remember you always want to try and factor, see if you can reduce anything. Can I factor anything?
A 2.
You can factor out a 2 from the numerator, right?
Mhm.
When I do that, I get 2 times what?
2 times
7y plus 15 over, and then my denominator is 20y, y minus 3, y minus 2.
Okay.
Once you factor, then you want to see if you can reduce anything. Can I reduce anything? The 2 and the
2 and the 20.
20.
So 1,
2 and the 2 is 1, 2 and the 20 is
10,
10. So what is the final answer?
1 over.
No, no, no.
Oh, okay.
1 times
7y
plus 15.
plus
Just the
15.
summary on the one. And then the y minus 3, y minus 2.
All right, so that's your answer. Now, what I was saying earlier is that the couple of you are going to want to multiply this denominator out. Don't do that. Leave it alone. Leave it in factored form. That's what we want. And if you went further with it and it was incorrect, you would not get full credit, even though this was correct right here. So leave it alone. Okay. So that was that should help you with B as well. But you could have done A and B together last class period. Okay. All right. So let's look at 10.1.
What's the title of it?
I think it's called radicals. Let's see. So 10.1,
Is it radical?
it's called radicals. So what we mean by radicals are like square root of 4, cube root of 10, the square root of x minus 3, the square root of x over 5, things like that. Those are radicals. So your radicals are the roots, cube root, fourth root, fifth root, sixth root, seventh root, and so on. Okay, so that's what we mean by radicals. Now, when we do 10.1 is easy enough to where you can use this idea. So when we talk about the square root of 16, you know what the answer is. What's the square root of 16? 4. So in this section, when thinking about what our answer should be, you want to use the idea that square root of 16 is 4 because 4 times 4 is what? 16.
16.
Okay? So the answer is 4 since 4 times 4 is your radicand, which is 16. Now let's talk about the terminology. All right, so the square root of 5. The 5 is called the radicand. The radicand. Now remember I said this was square root, right?
With a D at the end?
Yeah.
Radicand, the D. If this was the cube root of, let's say, 6, so the 6 would be the radicand. The index is the root part. So in this case, the index would be 3 because I'm taking the cube root. Here, if there's no number there, it's understood to be a,
1.
no. When we read this as square root. So square 2. So there's no number that's understood to be 1. Your index can never be, it's understood to be a 2. Your index can never be 1. So there's no 1th root. So the index here is, the index is 2. So square root, cube root, 4th root, 5th root, 6th root, and so on. Together, those are called radicals. So everything together is called a radical. All right, so again, if you had the square root of 36, you know the answer is 6 because 6 times 6 is what? 36. Okay, so that's the idea you're going to use in this section. You're going to use this idea here. Now in the next section, you're going to actually learn more about the notation in the next section, 10.2. So the first 2 sections are fairly easy, so don't mess that up. Okay, so this is page 602. This is going to be number 4. You want to find this right here. Now make sure you read it correctly. So how do you read this?
Square root
Square root of 9/25. And so I'm taking the square root of a fraction. Yeah, so some of you could look at this right away and say it's 3 over 5. Others of you, so you can go directly to the answer. Others of you may have to write it as the square root of the numerator divided by the square root of the denominator. And so the square root of 9,
3.
what times itself is 9?
3.
3. And then what's the square root of 25?
5.
5, because 5 times 5 is 25. Okay? So this right here is all you need to do these. In the next section, it's not going to be that simple, though, so you're going to learn more about the terminology, the notation in the next section. Okay, so let's look at number 8. You have negative square root of 9. What's the answer?
3.
Negative 3. Negative 3. Number 6, you have the square root of 0.04. Now let's suppose you don't have access to a calculator. You see, we did this without a calculator, so do this with a calculator. The square root of 0.04. Nope, don't take the calculator out.
0.02, right?
Nope. 0.2. Now here, the decimal is going to get you without a calculator. So here's how you want to think about this. You got to remember from last semester how to read. How do you read this?
400.
400ths. So make it look like number 4. It's 400ths. So this is the square root of 4 over 100, right?
Mm-hmm.
And so it's the square root of 4. The square root of 100,
10
which is 1/5. And what's 1/5?
0.
Oh, I'm sorry.
Yeah,
2/10, right? So that's, I mean, actually, you don't even need, you didn't have to do this.
Yeah.
What's 2/10 as a decimal?
0.2.
0.2. There's your answer. So with the decimal without a calculator, that's how you want to write it. You want to use your place value. You want to remember how to read it, not last semester, but maybe 2 semesters ago. How do I read 0.04? Well, please in place value, 0.04 is 400ths. And so I know the square root of 4 is 2, and the square root of 100 is 10, and so that's just 2/10, which is 0.2. All right. Okay, now here's where the next section. Well, no, it's actually. All right, let's just look at 10 for right now. I was going to say something, but I stopped myself. Here you have variables. Okay, so you're going to see in many cases, especially the next section. The next section is going to say, assume that the variables represent positive numbers. Assume that the variables represent positive numbers. And that's what for number 10, that's what it says. Assume,
Is that a 16 up there?
yes, 16.
So it'd be x to the fourth?
No, hold on. Assume the variables
That's right.
represent positive real numbers. Now that's important because there is one part of this section, a very small part. Now on your test, you're not going to have to worry about that little small part. But in my math lab, you do have to worry about that little small part. But there's a small part in this section where if it doesn't say anything about this, about the variables just being positive numbers, then you may need to use absolute values. And so we're going to talk about that when we get to it. So here you don't have to worry about that. So I'm not going to discuss that right now. So again, he said the answer was x to the fourth. That's not true because you're not using what we just talked about. When we said the square root of 36 was 6, you knew it was 6 because 6 times 6 is what? 36. He said this. He said the square root of x to the 16th is x to the fourth. Is that true? Is x to the fourth times x to the fourth x to the 16th? No, it's x to the 8th.
Okay.
So what should the answer be? X to the 8th.
Oh,
Because x to the 8th times x to the 8th is x to the what? 16. Since x to the 8th times x to the 8th does equal what? X to the 16. So remember, all I told you, in order to get through this section, you just have to know that the square root of 36 means 6 times 6. Is 6 because 6 times 6 is 36. That's all you have to remember for this. In the next section, it gets a little bit more complicated, so that's where we're going to talk about notation a little bit. Okay? All right, let's look at 12. Square root. Now, all of you should be able to get this now. So don't say it out loud. Write it down. Write what you think the answer is. The square root of 64y to the 20th. Write it down. Hopefully, all of you will get the correct answer. So you have 5, 4, 3, 2, 1. You're done. What's the answer?
8y to the 10th.
8y to the 10th. It's 8y to the 10th because 8y to the 10th times 8y to the 10th is 64y to the 20th. All right. Let's look at number 20. The cube root of 27 is what? What number times itself what?
3.
3 times is 27.
3.
3. Answer is 3.
So that's how that works.
24. Cube root of negative 125. Don't use a calculator. What number times itself 3 times is a negative 125? Not 5, negative 5.
Oh,
Because a negative 5 times a negative 5 is 25. 25 times a negative 5 is what?
124.
Negative
Negative
125.
that would have been
Okay, number 26. Cube root of x to the 15th. What times itself 3 times is x to the 15th? X to the
So
5th. It's x to the 5th.
Oh, because it's exponent. God. All right.
Because x to the 5th times x to the 5th times x to the 5th is what?
x to the 15th.
Now the next session you're gonna I'm trying to get you to that one of the patterns that you're gonna need for next section in 10.2. Do you see the pattern here? How can I get the exponent real quickly?
You just
Can
add.
you just divide the 3 into the 15?
All right, very good. You say 15 divided by 3 is what? 5. Here, 20 divided by what? 2 is what? 10. That's what you're going to use in the next section. And there's a notation though that you're going to see why that's true when we get to it. There's going to be a notation as to, well, why do I divide? But that's how you get it. So if I had this, let's say you had this one. Well, let me just do this. Suppose you had the 5th root of x to the 30th. What would that be? X to the 6th. So don't in your mind say what times itself 5 times x to the 30th. You know it right away. It's x to the what? 6. Because 6 plus 6 plus 6 plus 6 plus 6 is 30. So that's all you do. So you just take the exponent that's in the radicand divided by the index. Now, that there is what we just did, 30 divided by 5, is a rule that you're going to learn in the next section. All right, what about 28? 28, you have the cube root. That's a cube root of negative 64 x to the 6. So you'll be able to get the variable right away. But what's the cube root of negative 64? That's what you got to think about. What times itself? No, not 4, but
Negative 4.
negative 4. So what's the answer now?
Negative 4 x to the
X to the second. There's your answer. Because negative 4x to the second times negative 4x to the second times negative 4x to the second is negative 64x to the 6. X to the 6. All right, now, on my math lab, you're going to see something like number 32, and you have the square root of negative 16. Now, okay. So what times it? What real number times itself 2 times is negative 16?
4 negative 4.
No, it's got to be the same thing. You got to say 4 times 4, negative 4 times negative 4. You can't just say 4 and then negative 4. It's got to be that same thing.
Try it.
What real number times itself? So like 8 times 8, 9 times 9, 6.3 times 6.3. Things like negative 4 times a negative 4 is not a negative 16.
It's not.
It's a positive 16. What real number times itself is a negative 16?
Oh, well, no, that wouldn't be by itself either. Hell, I ain't got a clue.
8 times 8
I
is
was
a
thinking
positive
maybe 16 to
64.
1, but that don't even work.
No, it's got to be that same
Yeah, I was
number.
gonna say, we ain't got a clue. But yeah,
There isn't a real number
What?
times itself that's a negative
trying to warp
16.
our brains like that, we don't know.
In fact, if you think about it, guys, if you think about it, any real number times itself is it's either going to be 0 or a positive number. It's never going to be negative. A positive times a positive is a positive. A negative times a negative is a positive, right? No real number times itself, notice I say the real number, no real number times itself is a negative number. It's either going to be positive or 0. 0 times 0 is 0. 4 times 4 is positive. Negative 8 times a negative 8 is positive. So in the math lab, you're going to say this. You're going to say not a real number. Now, this is where we headed with this at some point. So it's not a real number, right?
Mm-hmm.
But it is a number. It's just not a real number. So there is a section in chapter 10, and you may remember this from high school algebra 2 or advanced math, imaginary numbers. So
Once I got through it after one, I said, the hell with this.
in this section, you're going to say not a real number, okay? In a future section of chapter 10, you're going to now say that's just for I. So that's where we're going to start talking about imaginary numbers in the
Alrighty
end
then.
of chapter 10, which we're going to need for some quadratic equations.
It's a number, it's not a real number.
Guys,
but
it's
it's
gonna be in your
number.
final, yeah.
So we have imaginary friends on our phone.
Girl,
The
some
math
of
is
you,
easy.
some of you already have imaginary friends.
How'd you come up with imaginary friends?
I'm just saying, some of you already have them.
His name is Skippy.
Talk about my friend like that.
All right, let's look at number 36.
Fake friends.
You have the fourth root of x to the 20th. What's the answer?
Okay, x to the 5th.
X to the 5th. 20 divided by 4 is 5. X to the 5th. 38. Let's see, 38, that is, I can't even read, it's so small. 38, okay, the fifth root of negative 32, x to the 15th. First of all, what's the fifth root of negative 32? What times itself 5 times is a negative 32?
Two?
Not 2.
Negative two.
Negative
Sorry.
2. Negative 2.
So
The fifth root of negative 32 is a negative 2.
negative 2x to the third.
Negative 2x to the third.
Can I break out my calculator yet?
Okay? No, because you need to know that. What times itself, because those are not big numbers, so you should be able to do this. And you don't even need your multiplication tables.
I was just trying to make sure I had the right number before I said something.
All right, 42. You have the square root. All right, well, some of you may struggle with this one. With the coefficient part. The variable part you should be able to do. What's the square root of x to the 8th?
X to the 4th.
Yeah. Now, what's the square root of 256? What times itself twice is 256?
What times
60.
itself twice is 128.
No,
No.
Or,
256
sorry.
divided by 2 is 128.
Yeah.
What times itself is 256?
64.
16.
Oh, 16, huh?
16 times
One
16
that-
is
multiples of computer.
256. So what's the answer?
16x to the 4th.
Actually, the 4.
Well, that one, you know about computer RAM, you know.
Okay.
Some multiple.
All right, so that's what this dealt with. Okay? All right, now, there is one little part here in my math lab where the absolute value is going to be important. So let's talk about that. So you got to listen carefully to this. You see how we had variables here? And the direction said this. Direction said, assume
It's positive.
assume all variables represent positive real numbers. Okay? The directions could have also said this. Assume all variables represent non-negative real numbers. Okay, so the direction says assume all variables represent positive real numbers, or the direction says assume all variables represent non-negative real numbers.
Pretty much means the same thing.
Y'all do understand that those are the same statement.
Mm-hmm.
Okay, positive non-negative real numbers means what?
Positive.
Positive real numbers are 0. Okay? Okay, non-negative real numbers would be positive numbers or 0. All right, so those are basically the same statement. So when you see that, you don't have to worry about absolute value. Now, after this section, we're going to assume all the variables from then on in chapter 10 are going to represent non-negative real numbers. But let's talk about what if it can be any real number. That's what we need to talk about. All right, so here's the idea. what is the square root of 4 squared? Square root of 4 squared.
Well, square root 4 squared is 16. So
Yeah,
4.
So 4.
It's 4. Square root of 4 squared is 4. Because 4 squared is 16. Square root of 16 is what?
4.
4. What's the square root of 8 squared?
8 squared is 64. So 8.
8? You agree?
Yeah.
Because 8 times 8 is 64.
So
Square root of
basically, if there's any number of squares, then it's going to be the number itself.
Not all the time. I'm pretty sure.
what's the square root of 128 squared?
28.
128. It kind of makes sense also because remember, if this was 16, we're asking ourselves, what times itself twice is 16? Well, 4 times 4 is 16.
Right.
If this is 8 squared, which is 64, what times itself twice is 64? Well, 8 times 8 is 64. The exponent tells us we're multiplying the base times itself twice. So here, my exponent is 2. I'm multiplying 128 times itself twice.
Yeah.
So the square root of 128 squared is just what?
28.
128. Okay, now what if you had this?
Here we go. Keep chicken over. I'm sure there's some truth. Oh, wait a minute.
Positive
Negative
4.
It's going to be positive 4.
All right, so I'm glad y'all didn't say negative 4.
No, because a
Well,
negative
you,
times a
well,
negative
you
is a
kind of
positive.
hinted that there was a kink coming, so we were on the lookout for
So it is a positive 4 because negative 4 squared is what?
Positive 16.
Positive 16, and the square root of positive 16 is 4.
Positive 4.
All right, so it's not negative 4. Now, if you want to say negative 4, you're going to have to say the absolute value of negative 4, which is what? 4.
4.
Okay, so that's where the absolute value is going to come in. So the square root of negative 7 squared is just what?
7.
7. Now, technically, it's the absolute value of negative 7, which is what?
So
7. Okay. Now, what if you had the cube root
that's
Of-
what it has.
2 cubed? Cube root of 2 cubed. Not 3.
Both of those are cubed? This
Yes.
is going to be 2.
It'll be 2. You said what?
I did it too.
Oh, I'm sorry.
Because I looked at the threes and counted.
Yeah, yeah. Cube root of 8 cubed.
Okay.
Cube root of negative 2 cubed.
2.
Nope. Negative 2.
Yeah, because you got negative 2 times negative 2, which is
Negative
positive 4
2
times negative
cubed
2.
is negative 8. What's the cube root of negative 8?
Negative.
Negative 2. So your question should become, well, why is it use absolute value here, but you didn't put it here? That should be the question.
Because it's cubed.
Okay? All right. So when you're told that the variables can be any real number, you got to first of all look at your index. Here, my index was what kind of number?
3.
Which is an odd number. So if your index is odd, you don't worry about absolute value at all. Because you can take the odd root of a negative number, right?
Right.
But we saw a while ago that you cannot take the even root of a negative number.
Right.
So when we did even root right here, we did even root,
You get absolute value.
my base here were positive numbers, right here they were negative numbers. So we still got to be careful though, because even though your index was even, doesn't necessarily mean you're always going to take the absolute value of that number. All right, so we're going to talk a little bit more about, well, when do I really need absolute value? Okay? All right. So let's go a little bit further with this. This is going to be, well, let's do this example right now. All right, so I'm going to put two things right here. And one of them is going to be this. One of them is going to be the square root of x squared. Then I'm going to put the fourth root of x to the fourth.
Okay.
Then I'm going to write the fifth root of x to the fifth. And let's say the sixth root of x to the sixth. And the seventh root of x to the seventh.
Okay.
All right, so look at those examples.
First one's X.
Okay. So you see that square root of x squared? In when we first started talking about this, if the direction set assumed that the variables represent positive real numbers, then you can tell me the answer right away. What's the answer?
X.
It's just x. Okay? The answer is just x. But now we're going to assume that the variables can be any real number. It can be positive or negative.
Negative x, because the negative times the negative would be a positive, correct?
Yep.
So it could be negative x.
Okay, so if I had the square root of negative 2 squared, let's say, versus the square root of 2 squared, okay? Here, what would this one be?
2.
The answer would be 2. Here, what would the answer be?
2.
2. Not
But
negative
the
2.
absolute
So you have to take the absolute value of negative 2.
Right.
So here, I didn't have to worry about absolute value. Here, I did. Because that's a 2. Because negative 2 times itself is
Positive.
4. Square root of 4 is 2. Okay? So the thing is this. Now notice this the same notation as this, except I just replaced x with a real number. So here, if x is positive, then the answer is just what? X. If x is negative, then the answer is going to be the absolute value.
Of negative X.
But I don't know which one it is. I don't know which one it is. I don't know whether x is positive or x is what? Negative. So I have to say the answer is going to be the absolute value of x. It don't just say x, it has to be what? The absolute value of x. Because if x is positive, I get 2. If x is negative, I got to take the absolute value of negative 2. All right, let's talk about this one. If you assumed that the variables represented positive numbers, then the answer here would be what?
X.
X. All right. So let's think about this for a moment. Suppose I had the fourth root of 2 to the fourth. What's the answer?
2.
2. What if I had the fourth root of negative 2 to the fourth?
Absolute value of 2.
Yeah, because you would say negative 2 times itself 4 times is what, 16? And what's the fourth root of 16?
4.
Positive 2.
Oh, yeah.
Positive 2. So you have to take the absolute value of negative 2 and you get positive 2. So again, I don't know whether it's positive or negative, so I have to say the answer is what? Absolute value of x.
Can I ask where, being that you ultimately wind up with the positive at the end, where the absolute value comes in the future for working something out?
What?
When you say like the absolute value of x, then you're basically saying the positive x. So where does
No. I'm not saying positive x. I'm just saying the absolute value of x. X would be negative. Then the absolute value of that negative number would be the positive number.
right, an absolute value of a positive number
Is a
it's still
positive
just a
number.
Positive number.
Yes.
So I guess I'm asking what the purpose for it is, for if it winds up coming out to be the same thing.
Well, it's not. So you can't say the answer is x or absolute value of x. I don't know if that's your question.
And that's, well, I guess I'm saying you put the extra step in when you think it could be a negative number, but ultimately in the end, it winds up equaling a positive number.
No. X can be negative,
Right.
okay? So if you simplify this, you can't tell me that the square root of x squared is just x, because x could be what? Negative. If you say it's just x, you're assuming x is always a positive number. x will be a negative number.
All right, I understand.
So it's it is a little bit difficult to understand, really, with this part here with absolute value. That's why after this section, you don't have to worry about that anymore. It becomes a lot easier for students.
Or are you being truthful about how easy it becomes, or is it just easy because you teach it and you say it's going to be easy?
Yeah, can you say
All right.
you've been saying every one of these chapters is easy.
Yeah. So when we talk about the fifth root of x to the fifth, then what is that?
I'm going to go with the absolute
X.
value.
No? Okay.
But, are we assuming that it's a negative number?
Well, okay.
Odd number.
It's an odd number. The index is odd. So I don't have to worry about whether this is even or I'm sorry, whether this is the x is positive or negative, because the index is odd. So it's just going to be x regardless.
Yeah.
Now let's see why. So what if I had the fifth root of 2 to the fifth? Well, what's the answer?
2 times 2 times 2 times 2 times 2.
What's the answer?
4.
2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32.
32.
It's just 2. It's just 2. But what if I had the fifth root of negative 2 to the fifth? It's negative 2.
Right.
So there's no absolute value there. So it's just x. It's just x. Your answer is whatever this is going to be, right?
Right.
That's what this is saying. So when I deal with an odd root, your answer is always going to be what that base is. Whereas here, when I deal with the even root, that's not always true. I can't say the answer is 2 or negative 2. It's always going to be both what? 2's. So that's why you need absolute value for x, because x could have been negative, but the answer is actually positive. Here, what do you think I'm going to need?
6 is absolute
Absolute value. I mean the absolute value here.
And for
Because think about it, guys. See here, when I raise a positive number to the fifth power or raise a negative number to the fifth power, that the opposite, I take the fifth root, I'm okay. Because the odd root of a positive number I can take, and the odd root of a negative number I can take. Here, though, when I raise a positive number to the sixth power, it's going to be positive. When I raise a negative number to sixth power, it's also going to be what? Positive. So you can't say the answer is just whatever that number is, because it's not. So if this is a negative 4, then the sixth root of negative 4 to the sixth power is not negative 4, it's what? The absolute value of negative 4, which is 4. Here it's just what?
X.
It's just x. It's just x, whatever x is. Whatever this number is, if this number is positive or negative, does not matter. It's whatever that number is. Here, whatever that number is, it does matter. Because if x is negative, I can't say the answer is negative 6, negative 7, negative 8. It has to be what? The absolute value of that.
So on even numbers, it's the absolute value. On odd numbers, it's just.
Yeah, but there's always a but.
Yeah, of course there is. This is math.
Okay, now what if you had this?
But wait, there's more.
What if you had the square root of 2 to the fourth power?
What do we assume? Oh, the square root of 2 to the fourth power? Yeah, now you're not, things aren't matching anymore, so it's going to be harder now.
2 to the fourth
Oh,
power.
the,
2 times 2 is 4 times 2 is 2 to the fourth power is 16, and the square root of 16 is 4.
To the second power?
What's 2 to the fourth power?
16.
16. What's the square root of 16?
4.
4.
That's what I said.
But then remember a while ago we were saying you just take the exponent divided by the index. What's 4 divided by the index 2?
2.
So that's 2 squared, which is 4.
That's what I said, actually.
What is
Thought was right.
the square root of 3 to the sixth power? That's 3 to what power?
Third.
No? Oh, third, you're right. 6 divided by 2 is 3, which is 27. Right? Okay, now let's go back to what I was trying to get here. All right, so the square root of 2 to the 5th is just 4, correct?
So you can't, I mean, so 2 to the second would not be a correct answer?
I mean, I don't see why you just wouldn't put.
No, because you know that 2 to the second is. 2 to the second is 4, so just write as 4. All right. The point I'm trying to get to is this. What if you had the square root of x to the 4th power?
Be x to the second power.
It would be x to the 2nd power. And the question is, do I need absolute value there? No, because x to the 2nd power is always what kind of number? Positive. What if you had the square root of x to the 6th power? What's that?
X to the third.
X to the 3rd. Okay, now listen.
Absolute value.
So a while ago he said this. He said, well, the index is always even, then I'm going to use absolute value. That's not always true. Okay, so let's talk about what we said a while ago. I can only take the square root of what kind of number? 0, what kind of number?
Positive.
Positive. Because you saw a while ago, the square root of negative 16 is not a real number, right?
That was being that way.
And I cannot take the square root of a negative number to get a real number. Okay? So let's talk about this right now. The square root of x to the 4th is x squared. Do I need absolute value here?
No.
No, because x squared is going to be what kind of number?
Positive.
Positive. The square root of x to the 6th, I know that when I take the square root of a number, that radicand must be what kind of number? 0 or
2.
positive. Okay? Is this right here always going to be a positive number? No. It can be negative if x is what? Negative. So I've got to put that in absolute value bars. That's all you got to think about. So if I had this, the square root of x to the 8th, what's that?
X to this,
X to the
X to the
fourth.
4th. Is x to the 4th always going to be a positive number or
Yes.
0? Yes.
Positive.
So you don't need absolute value. Square root of x to the 10th is what?
X to the fifth. Absolute
Notice
value.
x to the 10th is always what kind of number? Positive. Okay?
Square root of x to the 10th.
So whatever x is, if x is negative, x to the 10th is still what kind of number? Positive. If x is negative, x to the 5th though is what kind of number?
It's going to be absolute value.
Negative. But it must be what kind of number?
Absolute value.
If x is negative, a negative number raised to the 10th power is what kind of number?
Positive.
Positive. And the square root of that positive number is going to be
Positive.
positive. If x is negative, remember I've said x is negative. If x is negative, a negative number raised to the 5th power is what kind of number?
Absolute value.
Negative.
That's not what I'm
Negative,
asking.
negative.
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 Negative. So this is positive, this is negative, right? They don't match up. So what do I need here?
Absolute value.
Absolute value. So basically, here's the idea, and here's the pattern you're going to see here when you do that math lab part. If the index is even, and you simplify, and this exponent is even, if the index is even and this is even, you don't need absolute value. If the index is even and this is odd, you do what?
Absolute
Need
value.
absolute value. If the index is odd to begin with, you don't worry at all.
Right.
It's only when the index is even do you have to worry about this. It is difficult. It's not easy. It's a very difficult concept. So I'm not going to have that on the test. It's not going to be on the final. But the only reason we're going over is because it is on my math lab. And there's like maybe one or two like that.
Also in math algebra 101.
No, in Algebra 1, you're going to assume, in college algebra, you're going to assume that all the variables are positive.
Oh.
So you're not even going to talk about this in college algebra either, in the summer. In the summer. Okay? All right, so that's all this section was about. Just be careful with this, though. And all you got to remember, the only time you use absolute values if the direction says assume that the variables represent any real number. Any real number means positive, 0, or negative. So that's where you get to think about, well, am I going to need absolute value? All right, so the only time you're going to need absolute value is if the index is even, and when you simplified, the exponent turned out to be odd.
Odd.
Okay? And that's all that was. Now, let's look at this one. We just want to show you this one. This is number 48. Number 48.
It's a trick one.
Okay, 48. You have the fourth root of 16 x to the fourth. Okay? Fourth root of 16 x to the fourth. What's the fourth root of 16?
4. I mean, 2.
2.
2. What's the fourth root of x to the fourth?
X.
X. Okay, now the direction said this. Direction says, assume all variables represent any real number. So then you got to ask yourself, all right, well, that means I may need absolute value. Am I going to need absolute value?
It's an odd, so yes.
Yes, because that's x to the first. And you only put it around the variable part, because 2 is always what kind of number?
Positive.
Positives. So then the answer is just this. 2, absolute value of x. Don't say absolute value 2x, because my math lab, they're going to mark it wrong. It's 2 absolute value of
At
x.
least it gives you multiple tries.
Okay? All right. All right, I know this is a difficult concept with absolute value. But the rest of that should have been easy. The other part should have been easy.
Yeah, the stuff leading up to it.
Yeah. So, okay. All right, so
When you hit up with that, the root,
let me,
thing.